Lesson 17 has us begin looking at divisibility rules before we go into greatest common factor. So the objective for this lesson is that you will apply the divisibility rules specifically for 3 and 9 to understand factors and multiples. So first of all, I wanted to remind you what a multiple and a factor are. A multiple is a number when multiplied with another number, or when a number is multiplied with another number, you get a multiple. So you can find these by skip counting. So 4 times 2 equals 8. 8 is a multiple of 4 and 2. 5 times 3 is 15. So 15 is a multiple of 5 and 3. Now, when we skip count, we get a list of all the multiples for that first number. So when we skip count by 2, all the numbers after it are multiples of 2. Now, a factor is a number that another number can be divided by. So 10 can be divided by 2, so 2 is a factor of 10. Now, your divisibility rules, you will be using this throughout the lesson, so it's important that you write this down. The whole list I'll have up there so you can write while I explain them. You know a number can be divided by 2 if and only if its unit digit or its last digit is 0, 2, 4, 6, or 8. You know that a number can be divided by 4 if its last 2 digits are a number divisible by 4. So if your number was 124, so if our number was 124, my last 2 digits is 24. So I'd say, can 24 be divided by 4? The answer is 6, so that means it's yes, 124 can be divided by 4. The answer will not be 6. But because you can do this, there will be an answer to 124 divided by 4 without a remainder. A number can be divided by 5 if its unit digit or its last number is 0 or 5. A number can be divided by 8 if its last 3 digits are a number divisible by 8. So instead of looking at 24, you'd look at 124 and see if it could be divided by 8. And then you could do the whole answer. You can divide a number by 10 if its last number is a 0. And then these last 2 rules are for 3 and 9. 3 and 9, they share a rule. For both of them, all you do is you find the sum of the digits. And if the sum can be divided by 3, or if the sum can be divided by 9, then the whole number can be divided by 3 or 9. When I go into the examples and when you go into the problem set, you're going to see examples of this to help you clarify what that means. Now, if you go to your book, Lesson 17, the divisibility tests for 3 and 9, we're not going to do this first page, so you can put a line through it. We're going to go to that next page. I'm going to have you rewrite the divisibility rules. So I just gave them to you in your notebook. I want you to take it out, hit pause on the video, copy all the rules here so you can use it for your next page. Starting with the first example. This example shows how to apply the 2 new divisibility rules we just discussed. Explain why 378 is divisible by 3 and 9. So first, it tells me to expand it. So that would be 300 plus 70 plus 8. This is just a reminder of how you expand a number. We're going to skip B and C and go straight down to where we apply the rule. So what is the sum of the 3 digits? Well, I have a 378, which means I need to take 3 plus 7 plus 8. That gives me 18. Is 18 divisible by 9? Yes. Is the number 378 divisible by 9? Yes, because the sum of the digits is divisible by 9. Is the number 378 divisible by 3? Yes, because the sum of the digits is divisible by 3. 18 divided by 3 is 6. 18 divided by 9 equals 2. And then the whole answer, 378 divided by 9, you get a 4. That's a 36 bring down your 8, that's 18 divided by 9 gives me a 2. And so my answer then is 42. And then down here, 378 divided by 3 goes in there once. Bring down the 7. 7 divided by 3 is 2. And then I get an 18. 18 divided by 3 is 6. And your problem solved. So this is your proof that it does work. My next example, it says, is 3,822 divisible by 3 or 9? Explain why or why not. So the first step is I'm going to find the sum of my digits. 8 plus 3 is 11, plus 2 is 13, and plus 2 is 15. So then I say, can 15 be divided by 3? You get a 5, so yes, the sum of the digits can be divided by 3. And then I say 15 divided by 9. Nope. No, it cannot be divided by 9 because the sum cannot be divided by 9. And that's all you're doing. So I'm going to have you go ahead and hit pause on the video. I want you to work with a partner and do exercises 1 through 5. You're going to just apply the divisibility rules. And when you get that done, you can hit play again, check your work, and then bring it up to me so I can make sure that you've written everything down that I have in your notes. Your answers for your exercises. So number 1, you should have only circled 3. And the reason that you would have only circled 3 is that the sum of the digits is 21. And 21 can be divided by 3. It cannot be divided by 9. And then for 4, my last two digits are 38, and 38 cannot be divided by 4. That's why you can't divide by 4. You only need to write what I wrote. Number 2, it can be divided by 3, 9, and 5. The sum of the digits, 3 plus 4 plus 5 plus 1 plus 5 is 18. 18 can be divided by 9 and 3, which follows the divisibility rule for 9 and 3. And then the number ends in 5, which follows the divisibility rule for 5. And that's why you could circle all of those. Number 3, 10,534,341. You would have only circled 3. The sum of the digits is 21. 21 can be divided by 3. It cannot be divided by 9. And if number 2, the last digit is not a 2, 4, 6, or 8. Or you could say it's not an even number, so it can't be divided by 2. Number 4, you would have circled 3, 9, and 10. 3 and 9 follows the divisibility rule because the sum of the digits, 4 plus 3 plus 2 plus 0 equals 9. 9 divided by 3 is 3. 9 divided by 9 is 1. So the sum of the digits can be divided by 3 and 9, making them both factors. And then it ends in a 0, and that's why it can be divided by 10. So all 3 of these are factors. And then we have number 5, 6,240. It does follow the divisibility rule for 3 because the sum 6 plus 2 plus 4 plus 0 is 12, and 12 can be divided by 3. 12 cannot be divided by 9, so it isn't 9. And the last 3 digits is 240. 240 divided by 8 equals 30, so it follows the divisibility rule for 8. At this point, I want you to bring me up the book so I can make sure you've taken the notes on all the pages that I asked, and then you will go on to the problem set. You only need to do the 3 questions on the exit ticket, and then only 4 and 5 on the problem set.